What is Angular? Angular is a platform and framework for building single-page client applications using HTML and TypeScript. Created by Google, it enables developers to build applications with a web browser as the platform, using a component-based architecture and a rich set of features to create sophisticated, responsive, and scalable user interfaces. The provided code sample is a basic Angular module declaration using TypeScript. It begins by importing necessary Angular core components. @endModule is a decorator function that takes a single metadata object whose properties describe the module, including declarations, the view classes that belong to the module, imports, other modules that export components services that the module needs, and Bootstrap, the main application view, called the root component, which hosts all other app views. App component is the root component here, and browser module is imported to be able to run the app in a web browser. The app module class itself is declared with the export keyword, allowing it to be used elsewhere in the application. History and versions of Angular. Angular is a popular open-source front-end web application framework. It was developed by Google engineers Adam Abrons and Misko Hevery and initially released as AngularJS, Angular 1.x, in October 2010. AngularJS was designed to make both development and testing of front-end applications easier. But as web application requirements grew more complex, AngularJS began to show limitations. This led to a complete rewrite of AngularJS, which resulted in the creation of Angular, also known simply as Angular 2+, in September 2016. Each version of Angular from Angular 2 and above is simply known as Angular without the version suffix. The framework has been evolving since, with Google following semantic versioning and periodically releasing new versions. While AngularJS version 1.x refers to the first iteration of the framework, modern Angular refers to versions 2 and above, which were a complete rewrite utilizing TypeScript. Beginning with Angular 2, each major release is named by just incrementing the version number, Angular 4, Angular 5, etc. Noteworthy is that Angular 3 was skipped to avoid confusion due to the misalignment of the router package's version, which was already distributed as v3.3.0. Angular adopts a time-based release cycle with a new major version planned every 6 months. Angular ensures ease in upgrading by trying to make the versions backward compatible. Angular's architecture is modular, embracing decoupling, which allows for more flexible development and better performance optimizations. It remains a popular choice for developers looking to create dynamic, modern web applications. Angular versus AngularJS. Angular and AngularJS are both web application frameworks developed by Google, but there are key differences between the two. AngularJS is the original version which was released in 2010, and Angular, commonly referred to as Angular 2+, is a complete rewrite that was released in 2016. The following explanation highlights the main differences, but doesn't include code since the comparison is conceptual. AngularJS version 1.x utilizes JavaScript and is based on the Model View Controller (MVC) architecture that facilitates the development of dynamic web applications. Angular versions 2 and above is built on TypeScript and embraces a component-based architecture, which allows building more modular and maintainable applications. Angular is faster, more efficient, and offers improved functionality, such as mobile support, strong typing with TypeScript, and easier component communication compared to AngularJS. These differences result in Angular being more suited for enterprise-level applications and complex projects. Advantages of Angular. Angular is a widely adopted framework for building web applications. Developed and maintained by Google, it offers a range of advantages that make it an attractive option for both developers and businesses. Angular is known for its ability to create dynamic, single-page applications (SPAs). Its data binding feature reduces the need for boilerplate code, making the development process faster and reducing chances of error. The MVVM, Model View View Model, architecture ensures a clear separation of concerns. Angular's modularity helps in organizing code neatly and promotes reuse. It is TypeScript-based, which brings strong typing and object-oriented features to the table. Angular's CLI is a powerful tool that simplifies tasks like bootstrapping a new project, generating components, and running tests. Angular's built-in services and dependability injection make it easier to develop and test applications. Finally, the framework has a vast and active community, which means finding help and resources is usually easy. Architecture and building blocks of Angular applications. Angular is a platform and framework for building client-side applications using HTML, CSS, and TypeScript. It implements core and optional functionality as a set of TypeScript libraries that you import into your apps. The basic building blocks of an Angular application are ng modules, which provide a compilation context for components. An application always has at least one root module that enables bootstrapping and typically has many more feature modules. The architecture of an Angular application relies on certain fundamental concepts. The main building blocks are ng modules, which are containers for a cohesive block of code dedicated to an application domain, a workflow, or a closely related set of capabilities. They can contain components, service providers, and other code files whose scope is defined by the containing ng module. The root module, typically named app module, is the starting point of the app. Other ng modules can be feature modules or shared modules that can be imported into any other ng modules. Node.js and NPM installation. To start building applications with Angular, you need to set up your development environment. This includes installing Node.js and NPM, Node Package Manager. Node.js is a runtime environment that allows you to run JavaScript on the server side. NPM is a package manager that makes it easy to install and manage dependencies for your JavaScript projects. The provided code is not something you would execute in a terminal, but rather a set of instructions. For Windows or Mac OS, you should download the suitable installer from the official Node.js website and then execute it, following the on-screen instructions to complete the installation. If you're using a Linux distribution like Ubuntu, you can install Node.js and NPM through the terminal using the package manager with the commands listed. The sudo apt-get update command updates your package list, and the install commands set up Node.js and NPM on your system. After installation, you can verify the installation by running node v and npm and v to print their respective versions. Angular CLI installation and usage. The Angular command line interface, CLI, is a powerful tool that simplifies the process of initiating, developing, scaffolding, and maintaining Angular applications. To install Angular CLI, you will need Node.js and NPM, Node Package Manager, installed on your system, as Angular CLI is distributed as an NPM package. This command installs the Angular CLI globally on your machine using NPM, which allows you to access it from any directory in your system. The -g flag stands for global, which means that the package will be installed globally rather than in the local Node Modules folder of a project. After installation, you can create a new Angular application, run a development server, generate components, services, and other entities with the CLI commands. Creating a new Angular project. Creating a new Angular project is the first step in building an Angular application. This is facilitated by Angular CLI, which is a command-line interface tool that you use to initialize, develop, scaffold, and maintain Angular applications. The command ng new project name creates a new directory called project name and sets up the initial Angular project structure within it. This includes creating configuration files, installing necessary NPM packages, and generating the default app components. Once this process is complete, you can navigate into the newly created project folder and start the development server to see your new app in action. Understanding project structure. After setting up a new Angular project with the Angular CLI, you'll be presented with a specific directory structure. This structure organizes the project in a logical manner, separating different kinds of files and functionalities. It's essential to become familiar with what each directory and file is responsible for to navigate and maintain the application effectively. An Angular project typically includes the following directories and key files. src/ contains the source code for the Angular application. app/ within houses the components, services, and other files that you create. Assets is a place for static assets like images and styles. Environment/ contains the configuration files for different environments. Key files include index.html, the app's entry point, main.ts, bootstraps the application, polyfills.ts. helps with browser compatibility, and styles.css, global styles. Additionally, the Angular JSON file at the root configures Angular CLI behavior, and package.json manages the project dependencies. Running the application. After you have set up your Angular development environment and created a new project, the next step is to run your application to see it in action. In Angular, this is typically done using the Angular CLI command line interface. The command ng-serve compiles the application and starts a web server. The nash open, or masho flag, is optional and tells the CLI to open the application in your default web browser after it has finished compiling. By default, the application will be available at 8/localhost 4200/. When running, the Angular CLI will also watch for any file changes and recompile the project automatically, allowing for a smooth development experience. Introduction to TypeScript. TypeScript is a strongly typed programming language that builds on JavaScript, giving you better tooling at any scale. It's a superset of JavaScript, which means that all JavaScript code is valid TypeScript code. TypeScript offers additional features like static typing, interfaces, and classes, which enhance the development process, helping us to catch errors early in the development cycle. In this snippet, we declare a variable message with the type string, which tells TypeScript that message should always be a string. The colon syntax, string, is used to annotate the variable's type. TypeScript will enforce this type, helping to prevent bugs, like assigning a number to message later in the code. We then log the message to the console. If you try to assign a non-string to message, TypeScript will show a compile time error. TypeScript configuration. TypeScript is configured using a special file named tsconfig.json. This file specifies the root level files and the compiler options required to compile a TypeScript project. The code block is a basic example of a tsconfig.json file. In the compiler options object, target specifies the ECMAScript target version. Module sets the module system, here CommonJS. Strict enables all strict type checking options. And smodule interop allows default imports from modules with no default export. Outdir specifies the output directory for the compiled JavaScript files. The include array determines which files the compiler should include in the compilation process, with /stat indicating all files in the source directory and its subdirectories. Data types and variables. TypeScript enhances JavaScript by adding type annotations that enable the compiler to understand the kind of data being used. Let's explore the basic data types in TypeScript and how to declare variables with those types. This code demonstrates various TypeScript variable declarations with type annotations. IsDone is a Boolean, decimal is a number, and color is a string. Arrays are denoted with number, while tuple demonstrates a fixed size array of multiple types. The unknown type indicates a value that could be anything. Enums allow for a set of named constants. Here, color is an enum. Any is used for variables whose type can change or is not known. Functions with no return value are given the void type. TypeScript recognizes undefined and null as their own types for variables specifically set to those values. Functions and arrow functions. In TypeScript, functions can be created in several ways. Traditional functions enable you to encapsulate reusable code. Arrow functions provide a more concise syntax and lexically scope the this parameter, which is particularly useful when working with callbacks in classes. The given code defines two function expressions. The add function is a traditional function that takes two parameters x and y of type number and returns their sum also as a number. Similarly, we define subtract using arrow function syntax, which performs subtraction and offers the same types for parameters and return value. Both functions achieve similar results but demonstrate different syntaxes and use cases within TypeScript. Interfaces and classes. In TypeScript, interfaces are used to define the shape of an object. They can specify the properties that objects must have, including their types, as well as method signatures. Interfaces are a powerful way to define contracts within your code, as well as contracts with code outside of your project. The code defines an interface named person with two properties, name and age, and a method greet. An object user of type person is declared, which correctly implements the interface by providing the name, age, and greet properties, along with their respective types. The greet method takes a string argument and logs a greeting to the console. Access modifiers and properties. In TypeScript, access modifiers are keywords that set the accessibility of classes, methods, and properties. The three basic access modifiers are public, private, and protected. By default, member variables and methods are public, but you can make them private or protected to restrict their visibility. TypeScript also supports getter-setter accessors as a way of intercepting accesses to a member of an object. This TypeScript code defines a class, employee, with a private property full name that is not directly accessible from outside of the class. The class also includes a constructor to set the initial value of full name. Public get and set accessors are provided for score full name, which act as the public interface to get and set the value of full name while enforcing some validation logic. When we create an instance of employee, we can access the name via the getter-setter, but not the full name property directly. Attempting to set the full name to a string shorter than 3 characters results in an error message thanks to our validation logic. Modules and namespaces. Modules in TypeScript are a way to organize and encapsulate code. Each module can contain both code and declarations. TypeScript uses the ECMAScript 2015 module syntax, i.e. import and export. A module might export several variables, functions, or types, which can then be imported and used in other modules. In the code, calculator is a module that exports a function called add. The add function takes 2 parameters, x and y, which are both numbers, and returns their sum. Other modules can now import calculator and use its add function. Understanding components. Components are the building blocks of Angular applications. A component controls a patch of screen called a view through its associated template, which defines a segment of HTML to render. Each component consists of an HTML template, a TypeScript class, and a CSS style. In this code snippet, we are defining an Angular component using the @component decorator. The selector property determines the custom HTML tag for using this component in other templates. Template URL points to the HTML file for the view, and style URLs is an array of CSS file paths applied to this component's view. The @component class contains the logic for the component, where title is a property that can be bound within the template. Creating components with Angular CLI. In Angular, components are the building blocks of your application. They manage a view, data, and logic on the page. Angular CLI provides a fast and easy way to create components with the ng-generate-component command, which not only creates the component files, but also declares the component in the appropriate ng module. When you run the command ng-generate-component my-new-component, Angular CLI performs several actions. It creates a new directory called my-new-component with 4 files inside it: a TypeScript file .ts for the component's logic, an HTML file .html for the template, a CSS file .css for styling, and a spec file .spects for testing. Additionally, it updates the app.module ts file, declaring the new component in the @ng module decorator, specifically in the declarations array. This registers the component with Angular so it can be used in the application. Component structure and metadata. In Angular, a component is a TypeScript class where you can manage a piece of the UI. A component consists of a class that handles data and functionality, an HTML template that determines the view, and component-specific styling. Components use metadata to define how they interact with their host element and with other components. The @component decorator function is used to mark a class as an Angular component and provide metadata which determines how the component should be processed, instantiated, and used at runtime. In the code snippet above, selector defines the HTML tag where the component will be used. Template URL specifies the path to the HTML file that represents the view template for the component. Style URLs is an array of paths to style sheets for styling this particular component. Finally, export class myComponent defines the new component class where the business logic resides. Modules in Angular. Modules are a fundamental concept in Angular, which helps in organizing code by bundling components, directives, pipes, and services that are related into cohesive blocks. Each Angular app has at least one module, the root module, which is conventionally named app module. Modules can also import functionality from other modules and export their own for use in other modules. In the given code, the app module is defined by using the @any_module decorator. The declarations array is where you would list all the components that belong to this module. Imports is used for bringing in other modules like browser module, which is needed for any web application. Providers is where you can list services that this module will contribute to the global collection of services. However, this is largely being replaced by the provided in property of injectable. Finally, Bootstrap tells Angular which component to use as the entry point for the application, often the root component. This code defines the structure of app module, the main application module in an Angular application. Decorators, component, ng module. In Angular, decorators are functions that modify JavaScript classes. The @component decorator identifies a class as an Angular component, adding metadata that defines how the component should be processed, instantiated, and used at runtime. This code snippet demonstrates the use of the @component decorator to define a new Angular component. The decorator takes an object as an argument, specifying the component's selector, template URL, and styles. The selector is the custom HTML tag that will be used to invoke the component. The template URL and style URLs define the external HTML template and CSS styles for the component, respectively. Through this decorator, Angular knows how to treat the example component class, linking it with the specified template and styles. Data binding, interpolation, property binding, event binding, two-way binding. Interpolation is a form of one-way data binding used for rendering dynamic content in HTML. It utilizes curly braces to embed expressions within template literals. The code snippet above uses interpolation to bind the message property from the component class to the view. Whatever value message holds, it will be displayed at the location of message in the HTML template. Lifecycle hooks. Angular components go through a lifecycle from initialization to destruction. Angular provides lifecycle hooks that give us visibility into these key life moments and the ability to act when they occur. A common use case is to perform tasks like component initialization, data fetching, or cleanup operations. In the code example, sample component implements two lifecycle hooks, onInit and onDestroy. By implementing onInit, you can perform initialization work, like fetching data when the component is created. The ng onInit method is called right after the component's creation. OnDestroy is useful for cleanup tasks. When the component is about to get destroyed, Angular calls the ng onDestroy method, allowing you to free resources or unsubscribe from observable streams to prevent memory leaks. These hooks ensure you have full control over the component's lifecycle. Understanding directives. Directives are classes that add additional behavior to elements in Angular applications. There are three types of directives in Angular: components, attribute directives, and structural directives. Here we'll focus on a simple example of an attribute directive that changes the color of the text in a paragraph. This code snippet defines a directive highlight directive that changes the background color of the HTML element it is applied to yellow when the mouse enters its area, and reverts it when the mouse leaves. The @directive decorator indicates that this class is a directive and allows us to specify the selector app_highlight, which can be used on any element. The host property listens for mouse enter and mouse leave events, calling onMouseEnter and onMouseLeave methods respectively. These methods change the element's background color by directly manipulating the DOM using elementRef. Types of directives: component, structural, attribute. In Angular, directives are classes that add additional behavior to elements in your Angular applications. There are three main types of directives: component directives, structural directives, and attribute directives. Let's explore each with brief examples. Component directives are the most common and complex directives, defining components with templates, metadata, and logic. The @component decorator indicates a class is a component with its UI definition. Structural directives alter the DOM layout by adding, removing, or manipulating elements, e.g. an eng4 for repeating a template for each item in a list. Attribute directives change the appearance or behavior of an element, component, or another directive, e.g. engstyle for dynamic styling. Each directive type serves a distinct purpose within an Angular application, enhancing capability and flexibility in component and template manipulation. Built-in structural directives, if, and for, switch. The if directive is used to conditionally include a template block in the DOM. It adds or removes elements based on the truthiness of the provided expression. In this example, the div element will only be added to the DOM if isLoggedIn evaluates to true. If isLoggedIn is false, the div element and its contents will not be rendered. This is particularly useful for showing or hiding elements based on certain conditions. Built-in attribute directives, ngClass, ngStyle. Angular provides powerful attribute directives to dynamically control the styling and class attributes of elements. ngClass and ngStyle are two such directives that enhance element styling capabilities based on component logic. This code snippet demonstrates the use of ngClass and ngStyle directives on a div element. With ngClass, the active class is applied when isActive is true and disabled when false. ngStyle applies a green color and bold font weight when isActive is true, and a red color with normal font weight otherwise. These directives make it easy to apply conditional styles and classes based on component variables, enhancing dynamic styling capabilities. Creating custom directives. In Angular, directives allow you to attach behavior to elements in the DOM. Custom directives are a powerful feature that lets you create your own reusable directives. We will create a simple directive that changes the color of the text of the element it is applied to. This code snippet defines a custom directive named changeColorDirective. The @directive decorator is used to define the custom directive with a selector @changeColor, indicating how the directive will be used in HTML. The class changeColorDirective injects elementRef into its constructor, allowing access to the host element. The directive changes the color of the host element's text to blue by modifying its native element.style.color property. To use this directive, simply add the @changeColor attribute to any HTML element in your component's template. Understanding pipes. Pipes in Angular are a way to transform data in templates. They are simple functions that take an input data and transform it to a desired output format, making them extremely useful for formatting strings, dates, numbers, and more. Angular comes with a set of built-in pipes, and you can also create custom pipes. In this code snippet, we use the built-in date pipe to format a birthday variable into a specific format, mmb. Here, birthday is a JavaScript date object in our component, and we want to display it as mm.yy format in our template. The pipe operator, for, applies the date pipe to the birthday value, transforming the date into a more readable string format according to the specified pattern. This is a common use case for displaying dates in Angular applications. Built-in pipes. Angular provides several built-in pipes that you can use to perform common transformations directly in your templates. One of the most frequently used is the date pipe, which formats a date according to the locale rules. In this example, we'll demonstrate how to use the date pipe to format a date object. In this code snippet, birthday is a JavaScript date object in the component. The pipe operator plural applies the date pipe with the argument full date, specifying the format. Angular transforms the birthday date into a more readable, localized full date format. For instance, if birthday is January 1st, 2020, the output might be Wednesday, January 1st, 2020, depending on the locale. Creating custom pipes. In Angular, pipes are simple functions you can use in template expressions to accept an input value and return a transformed value. Creating a custom pipe allows you to define custom data transformations that can be used directly within your Angular templates. First, we import pipe and pipe transform from @angular/core. We define a pipe named exponential strength using the @pipe decorator, which expects a name property. The pipe class implements pipe transform interface, which requires a transform method. This method takes an input value and an optional exponent argument, returning the input value raised to the power of the exponent. To utilize this custom pipe in a template, you would use it like so. Value, exponential strength, exponent. Pure and impure pipes. In Angular, pipes are a way to transform data before displaying it. There are two types of pipes, pure and impure. Pure pipes are only executed when it detects a pure change to the input value. A pure change is either a change to a primitive input value, such as string, number, boolean, or a changed object reference, such as date, array, object. Impure pipes are executed on every component change detection cycle, which means they can deal with mutable data or perform more complex transformations. Pure pipes are highly performant because they are executed only when a relevant change occurs, making them ideal for transforming immutable data or performing operations that don't require the latest input on every change. On the other hand, impure pipes, while less efficient due to their execution on each change detection cycle, are necessary when you have to work with data that changes over time, or in ways not easily trackable by Angular's change detection mechanism, e.g. filtering or ordering mutable arrays. It's essential to use impure pipes judiciously to avoid performance pitfalls in your application. Overview of forms. In Angular, forms are essential for capturing and validating user input. Angular provides two approaches to handle forms: reactive forms and template-driven forms. Reactive forms offer more flexibility and control, making them suitable for complex scenarios. Template-driven forms are simpler and more straightforward, making them ideal for basic scenarios. Angular forms are a critical part of most web applications, allowing users to enter data that can be validated and processed by the app. While reactive forms are defined and configured programmatically, template-driven forms rely on directives in the template itself. Despite the differences in their approach, both methods provide robust tools for creating interactive and responsive form-based applications, including functionalities for data binding, validation, and form submission. Template-driven forms. Template-driven forms are a way to create forms in Angular by leveraging the power of two-way data binding with ng-model. This approach involves creating forms in your template, HTML, rather than in your component class, making it a straightforward method for building forms. In this code, a simple form with a single input field is created. The ng-model syntax is used for two-way data binding, syncing the input field's value with the component's name property. The name attribute on the input is necessary for Angular to register this input under the internal form model. When the user types in the input, the name property in the component gets updated in real time, and vice versa. This exemplifies the simplicity and power of template-driven forms in Angular. Reactive forms. Reactive forms provide a model-driven approach to handling form inputs whose values change over time. This approach is more robust and scalable as it offers more control, dynamism, and scalability. It involves creating a form model in the component class, which Angular then binds to the form in the template. Let's explore a basic setup. In this code, form group and form control are imported from @angular/forms, which are essential building blocks of reactive forms. A new form group named myForm is created in the component's constructor with two controls: first name and last name, both initialized with empty strings. The form group represents the form itself, with each form control representing an individual form element. This structure facilitates the tracking of value and validation status of each control independently. Form validation. Form validation is crucial in ensuring that user input is checked before submitting to the server. Angular provides a simple yet powerful set of tools for form validation. It supports both synchronous and asynchronous validators. Here, we'll focus on a simple template-driven form that uses built-in validators for common checks such as required, min-length, and email validation. This example introduces a basic form with an email input and a submit button. The form will validate the input before allowing the submission. In this code snippet, we define a simple form with an input field for an email. The ng-model directive is used to perform two-way data binding on the input element, making Angular aware of the element's state and content. The required and email attributes are Angular's built-in validators that ensure the field is not empty and contains a valid email address, respectively. Furthermore, error messages are conditionally displayed when the field is touched, has been interacted with, and the respective validation error exists. The submit button is disabled if the form is invalid, preventing submission of invalid or incomplete forms. Form control, form group, form builder. Form control is a fundamental concept in Angular for tracking the value and validation status of an individual form field. It is an instance of form control class. In the given code snippet, a new instance of form control is created with an initial value of an empty string. This form control can now be used to track the value and validation status of a single form field, such as an input for a user's name. Dynamic form controls. In Angular applications, sometimes we need to create forms dynamically based on data that might not be available at compile time. This requires adding, removing, or modifying form controls at runtime. Angular makes this possible through the form array and form group classes. The code snippet demonstrates how to implement dynamic form controls using Angular's reactive forms. It involves creating a form with a form array named users, allowing the addition and removal of user forms at runtime. The form array is managed through methods addUser and removeUser, which respectively adds a new form group to the form array and removes a specified form group based on its index. The form group instances represent the individual user forms and contain form controls for user information like name and age. This setup is essential for managing dynamic forms where the number of inputs is not fixed, such as in scenarios of editable lists or user-generated forms. What is a service? In Angular, services are broadly defined as any value, function, or feature that your application needs. A service is typically a class with a narrow, well-defined purpose. It should do something specific and do it well. Angular distinguishes components from services to increase modularity and reusability. By separating a component's view-related functionality from other kinds of processing, you can make your component classes lean and efficient. The provided code demonstrates the basic structure of an Angular service using the @injectable decorator. This decorator marks the class as one that participates in the dependency injection system. The provided root metadata means that Angular will provide a single, shared instance of some service across the application, improving modularity and reusability. The sum method function inside the service can be invoked from any component or other services, fostering a clean separation of concerns. Creating a service with Angular CLI. In Angular, services are a great way to share information among classes that don't know each other. Creating a service using Angular CLI is straightforward and helps in maintaining clean code. This command creates a new service named myService. Angular CLI automatically appends service to the name you provide, if not already there, ensuring naming conventions are followed. It generates two files, myservice.services, and a spec file for testing, myservice.service.spec.ts. Inside myservice.service.ts, Angular CLI includes boilerplate code for a basic service class, ready to be filled with custom logic. Providing services. In Angular, services are a great way to share information or logic across components without needing to directly communicate between them. To make a service available to be injected into components or other services, you need to register it with an Angular injector. This can be done by providing it in the providers array of an ng module or a component. The code demonstrates creating a service in Angular with the @injectable decorator, signifying that this class is available to be injected as a dependency. The provided in root property means this service is provided in the root injector, making it a singleton and available throughout the app. As long as you are using Angular's dependency injection system, you can inject this service into any constructor in your application, allowing for easy access to its methods and properties without having to instantiate it directly. Dependency injection (DI) in Angular. Dependency injection is a core concept in Angular that allows a class to receive its dependencies from external sources rather than creating them itself. This makes your code more modular, easier to test and manage. Let's see how Angular's DI system works through a simple example. In this example, some service is created with the @injectable decorator, indicating it can be injected into other classes. The provided in root property means it's available throughout the app. Some component then injects some service through its constructor, relying on Angular's DI system to obtain an instance. By using private some service in the constructor parameters, Angular automatically provides an instance of some service enabling the component to use its functionalities. This illustrates the essence of DI in Angular, promoting a decoupled and more maintainable application structure. Hierarchical injector. In Angular, the hierarchical injector system is a robust mechanism designed to control how services are shared across the application. It allows for different instances of a service to be created and used at multiple levels in the hierarchy of components. This hierarchical nature enables more refined control over service instance sharing, resulting in modular and efficient applications. In this example, the data service is initially provided in the root of the application, provided in root, allowing it to be a singleton across the app. However, by also declaring data service in the provider's array of example component, a new separate instance of data service is created exclusively for instances of example component. Thus, example component and its children can use this specific instance, demonstrating the hierarchical injector in action. It allows components to override inherited service instances for more localized or specialized uses, adhering to modular and scalable application structures. Singleton services and provided in. In Angular, services are singleton objects that get instantiated only once during the lifetime of an application. The provided in property makes it easier to declare where a service should be provided. Commonly, services are provided at the root level, making them accessible throughout the app. In the given code snippet, we're defining a service named mySingletonService. The @injectable decorator indicates that this class can be injected as a dependency. The provided in root part specifies that this service should be a singleton and available application-wide. Angular automatically registers the service in the application's root injector, making it available for injection into any component without needing to explicitly list it in an ng-modules providers array. Introduction to the Angular router. The Angular router enables navigation from one view to the next as users perform application tasks. It interprets URL changes as actions to take, such as displaying a component's view. Let's start by setting up routing in a new Angular project. Here, router module is imported from Angular/router along with routes. Routes is an array of route definitions. Each route maps a URL path to a component. Router module.forRoute routes registers routes at the application's root level. Finally, we export app routing module, making it available throughout the application. This setup is fundamental for enabling navigation and rendering components based on the URL. Router configuration. Router configuration in Angular involves setting up routes that determine what view is displayed based on the URL. This is crucial for creating a single-page application, SPA, where navigation between different components doesn't require reloading the entire page. We define routes in a routes array, specifying the path and the component that should be loaded. In the provided code, an array of routes is defined where each route is an object with a path and component property. The path is the part of the URL that determines when the route is active. The component is what Angular should create and show when the route is active. The last route is a default route, redirecting an empty path to /dashboard, ensuring the application always starts at the dashboard component. The path match, full, ensures this rule only applies when the complete URL matches the empty path. Router outlets and routes. In Angular, a router outlet is a directive from the router module that acts as a placeholder where routed components are displayed. Routes define the navigation paths and associated components. Together, they enable navigation from one view to the next as users perform application tasks. The router outlet tag in the template is a placeholder for the components that get loaded by the router. The routes constant is an array of route objects where each route is mapped to a component. Path defines the URL fragment which will load the component, and component specifies the component to load when the path is matched. The routes are registered by passing them to the routermodule.forRoute method in the app module. Router link and router link active. In Angular, the router link is a directive that allows the user to navigate to different routes within the application. Router link active is another directive used in conjunction with router link to style the active link. These directives make it easier to manage navigation and the active state of links directly from the template. In this code snippet, router link is used on anchor tags to specify the application routes for navigation, /user and /about. The router link active directive automatically adds the active CSS class to the anchor tag when the route matches the current URL. This helps in visually indicating which page the user is currently on. The Angular router does the rest, ensuring the application navigates to the correct component based on the URL. Programmatic navigation. Programmatic navigation in Angular allows for dynamic routing based on certain conditions or events in the application. This method uses the Angular router to navigate between components without needing a link. It's helpful for navigating after an action is taken, such as submitting a form. The code snippet is a basic example of programmatic navigation in Angular. It uses the navigate method of the router service. The router is an instance of the router class, injected into the component via the constructor. The navigate method takes an array, where the first element is the path to navigate to. This method changes the current route to /SumPath, thus navigating the user programmatically. Route parameters and data. In Angular, route parameters allow you to pass data to your route handlers, making your application dynamic and responsive to user input. This is crucial for scenarios like navigating to a user's profile page, where the user ID can be passed as a route parameter. The above code snippet showcases how to define a route in Angular that accepts a parameter, in this case, a user ID. The route is defined in your routing module with a path that includes ID, indicating a placeholder for the actual user ID. Then, in the user profile component, we subscribe to parammap on the route service to extract the ID parameter. This way, you can access the user ID within the component and fetch or display the relevant user profile data. Guards can activate child, can deactivate. Angular provides route guards to protect routes and manage navigation based on certain conditions. Can activate decides if a route can be activated. Can activate child checks if child routes can be activated. And can deactivate controls navigation away from the current route. Here's an example implementing these guards. In the provided code, an auth guard service implements three interfaces: can activate child, and can deactivate from @Angular/router. Each method returns either a Boolean, a promise that resolves to a Boolean, or an observable that emits a Boolean to indicate if navigation should proceed. Can activate is used for deciding if a route can be accessed, can activate child for any child routes of a given route, and can deactivate is used for determining if it's okay to leave the current route, possibly after checking if any unsaved changes exist, or asking the user for confirmation. Communicating with back-end services using HTTP client. Angular provides the HTTP client module to communicate with back-end services. It makes HTTP requests to fetch or save data and returns an observable that emits the requested data when the response is received. This example demonstrates how to use HTTP client in an Angular service to make a GET request to a backend. Firstly, HTTP client is imported from @Angular-common/TP, and the service is annotated with @injectable to allow Angular to inject it wherever needed. The constructor injects HTTP client as a private property of the class. The fetch data method uses the HTTP property to send a GET request to a specified URL and returns the observable to the caller. This observable will emit the fetch data when the HTTP response is received. GET, POST, PUT, DELETE requests. In Angular, interacting with a server over HTTP is a common task, often done using the HTTP client module. This allows an application to communicate with backend services to perform CRUD, create, read, update, delete operations. Here's how to make GET, POST, PUT, and DELETE requests using HTTP client. This code snippet demonstrates making HTTP CRUD operations in Angular. For a GET request, you're retrieving data from a specified URL. A POST request is used to create a new record in the database, requiring you to send a payload, the data to be created. The PUT request modifies an existing record, also requiring a payload with the updated data. Lastly, the DELETE request removes a record from the database specified by the URL. All these operations use observables to handle asynchronous data. These operations return an observable that you subscribe to in order to get the result of the operation. Handling HTTP responses. In Angular, handling HTTP responses is crucial for understanding and utilizing the data returned from server-side APIs. The HT client module provides methods such as .get, .post, etc., which return observables. Observables help manage asynchronous data, like HTTP responses. Here, we will learn how to handle these responses effectively. In the provided code, this .http get/ape/data sends a GET request to the server. The .subscribe method is used to handle the response. It takes two arguments, a success handler and an error handler. The success handler, data equals console.log data, is executed when the request succeeds, logging the received data to the console. If the request fails, the error handler, error equals console.error, there was an error, gets executed, logging the error to the console. This pattern allows for effective handling of both successful responses and errors from HTTP requests. Observables and RxJS library. Observables provide support for passing messages between publishers and subscribers in your application. They are part of the RxJS library, which is a library for reactive programming using observables that makes it easier to compose asynchronous or callback-based code. This topic will introduce how to create observables and subscribe to them. This code demonstrates creating a basic observable using the RxJS library. Observable.create is called with a subscriber function that emits values using subscriber.next and signifies completion with subscriber.complete. The observable emits values 1, 2, and 3 immediately, then emits 4 after a delay of 1000 milliseconds, 1 second, and finally signals completion. The observable.subscribe method is used to listen to the values emitted by the observable, where next receives the emitted values. Error is called if there's an error during the observable execution, and complete is called once the observable completes its emission of values. Error handling. In Angular, when making HTTP requests using HTTP client, it's crucial to handle errors smoothly to improve user experience and application stability. Errors may occur due to network issues, server problems, or invalid user inputs. The RxJS catch error operator allows us to catch errors and handle them gracefully. In the given code, an HTTP GET request is made to /API/data using HTTP client. The pipe method is used to chain RxJS operators, and catch error is applied to intercept any errors that occur during the HTTP request. Inside catch error, a function is defined to handle errors, which logs the error to the console and then throws a new, more user-friendly error using throw error. This approach ensures that errors are not only caught, but also handled in a way that can be managed downstream in the application. Retrying requests. In Angular, when making HTTP requests, sometimes the requests might fail due to transient errors, like network issues. It's often desirable to retry these requests automatically. RxJS provides operators like retry and retry when that can be used for this purpose. Here, we'll focus on a simple use case using the retry operator. This code snippet demonstrates using the retry operator to automatically retry an HTTP GET request up to 3 times before finally throwing an error if it fails after those attempts. The retry operator is applied within the pipe method of an observable. If the request fails, retry attempts to resubscribe to the source observable, in this case, the HTTP GET request, the specified number of times. After the defined retry attempts, if the request still fails, catch error is used to handle the error appropriately, which might involve logging the error or displaying an error message to the user. Unsubscribing observables. In Angular, observables are used to handle asynchronous operations, such as HTTP requests. Subscribing to an observable means you are interested in the data it emits. However, failing to unsubscribe from observables can lead to memory leaks, as they continue to listen for events even if the component using them is destroyed. Therefore, it's important to unsubscribe from observables when they are no longer needed. In this code snippet, we first import the subscription from RxJS. We then declare a property, mySubscription, of type subscription. When subscribing to some observable, we store the subscription in mySubscription. Finally, in the ng-on-destroy lifecycle hook, which is called right before the Angular component is destroyed, we call unsubscribe on mySubscription. This effectively stops listening to the observable and prevents potential memory leaks. It's a best practice to always unsubscribe from observables in this manner to ensure resources are properly cleaned up. JSON Web Tokens, JWT. In the context of web applications, securing resources and APIs is crucial. JWT offers a compact and self-contained way for securely transmitting information between parties as a JSON object. This information can be verified and trusted because it is digitally signed. JWTs are commonly used for authentication and information exchange, facilitating a stateless authentication mechanism for the servers. This code demonstrates how to generate a JWT token using the Node.js library JSON Web Token. The JWT.sign method is used to create the token, taking 3 parameters: the payload, here an object with the user's ID, a secret key to sign the token, and an options object where you can specify token properties like expiration. The generated token can be used to authenticate API requests, ensuring that the requester has been authenticated. User authentication workflow. The user authentication workflow is a process to verify the identity of a user trying to access resources in an Angular application. This involves the user providing credentials, which are then validated against a database or a service. Upon successful validation, the user is granted access. Here, we'll focus on a simple login workflow using Angular and a fake backend service. In this code snippet, we attempt to log in by calling login on an authentication service, passing form values. Upon successful login, the response is expected to contain a token, which we then store in local storage. This token serves as proof of authentication for subsequent requests. We then navigate to the dashboard. If there's an error, such as invalid credentials, it's logged to the console. This illustrates the basic flow of user authentication in Angular applications. Adding a login form. To implement authentication in Angular, we start by adding a login form. This form will capture the user's credentials and submit them for verification. It's an essential step in managing access control in your application. The provided code snippet creates a basic HTML form for login. It includes fields for the username and password and a submit button. This form doesn't yet connect to any backend logic for authentication. To make it functional, you'll need to bind the form inputs to your Angular components model and handle the form submission event, where you'll typically call a service to authenticate the user with your backend. Securing routes with guards. In Angular, securing routes is essential to protect resources that require authentication or authorization. Guards are services that implement one or more interfaces provided by Angular's router, such as canActivate, to control access to routes. They return true if navigation to a route should proceed, or false if not. Here we'll create a simple auth guard to demonstrate securing a route. The provided code snippet demonstrates an auth guard implementation using the canActivate interface. The auth guard class implements the canActivate method, which decides if a route can be activated based on the user's authentication status. Here, isAuthenticated is hard-coded to false to simulate an unauthenticated user scenario. If the user is not authenticated, the guard redirects to a /login route using the router's navigate method and returns false, preventing access to the target route. If the user is authenticated, true is returned, allowing route access. This mechanism provides a simple yet powerful way to protect routes. Role-based authorization. Role-based authorization controls access to resources based on the roles assigned to a user. In Angular, this can be implemented through route guards that check a user's roles before allowing access to certain routes. Below is an example of a role-based route guard. The code snippet defines a role guard service that implements canActivate interface from Angular's router. It uses the canActivate method to check if the user's role matches the expected role defined in the route data. If the roles don't match, it redirects the user to an unauthorized page and returns false, preventing access to the route. Otherwise, it allows the navigation by returning true. This service must be provided in the app module and referenced in the route configurations to protect specific routes based on user roles. Component inheritance. In Angular, component inheritance involves extending a parent component class to share its properties and methods with child components. This technique can be useful for reusing logic and ensuring consistency across components. However, it's essential to use this pattern judiciously to maintain component cohesion and avoid complex hierarchies. In the provided code, base component is defined with a greet method, returning a greeting message. Derived component extends base component, inheriting its method. By calling this.greet within derived component, it demonstrates how inherited methods can be utilized in child components. The @component decorator defines metadata like selector and template, allowing Angular to identify and process the component. This pattern facilitates code reuse and simplifies extending functionality across similar components. Content projection with ng content. Content projection is a pattern in Angular that allows you to inject HTML content from a parent component into a child component's template. This is useful for creating reusable components that can display dynamic content. The ng content directive is used to mark where the projected content should be inserted. In the child component's template, the ng content tags define the insertion point for content coming from the parent component. When the parent component includes an app child component tag and places content between its opening and closing tags, that content is inserted into the ng content location of the child component. This technique allows for flexible component designs without tightly coupling the parent and child components. View children and content children. In Angular, both view children and content children are decorators used to query and access elements or directives from the component's view. View children references elements within the template of the component itself, while content children refers to elements passed into the component's content slots via ng content. In this example, @viewChildren is used to access child components within the template, identified by a local reference tag, childref. This is useful for accessing and manipulating child components directly from the parent component. @contentChildren, on the other hand, is used to access instances of child directive that are projected into the component through ng content. This is essential when developing components that accept content or directives from parent components. Both decorators extend component capabilities by allowing complex component interactions and querying capabilities within the Angular framework. Template reference variables. Template reference variables in Angular allow us to create a reference to a DOM element or directive within a template. This can be incredibly useful for directly accessing properties and methods of those elements or directives. In the provided code snippet, *myInput is the template reference variable that refers to the input element. This enables us to directly access the input element's properties, such as its value, from within our component's class. When the button is clicked, the loginput function is called with the current value of the input, which is accessed via myInput.value. This pattern allows for a more direct and efficient interaction with DOM elements, eliminating the need for additional binding or complex DOM manipulation. Dynamic component loading. Dynamic component loading in Angular allows for the dynamic instantiation and insertion of components during runtime. This technique is incredibly useful for building highly modular and adaptable applications. The example below demonstrates a simple use case of dynamically loading a component using Angular's viewContainerRef and component factory resolver. In this code snippet, the dynamic component loader component utilizes Angular's viewContainerRef to mark a location, ng template dynamic insert, in the template where the dynamic component will be inserted. The component factory resolver is used to create a component factory for the desired component, your dynamic component in this case. This factory then enables the instantiation of the component with the createComponent method of viewContainerRef, dynamically loading the component at runtime. It's a powerful way to add or change components based on certain conditions without the need for them to be present in the template from the start. Understanding state management. State management is an essential concept in Angular applications, helping developers manage application state in a predictable manner. It refers to how data is handled across your app and its UI components. For this example, we'll use a simple Angular service to demonstrate basic state management. The provided code example defines a basic state service using Angular's dependency injection. This service is designed to store and retrieve data, acting as a simple state management solution. It uses a private property data to hold state information, which is an object where keys represent unique identifiers for pieces of state, and values are the actual state data. The setData method allows for setting a value for a given key, while getData retrieves a value for a given key, returning null if the key doesn't exist. This example illustrates how Angular services can be used to manage state across components, promoting a cleaner and more organized application structure. Introduction to NGRX. NGRX is a framework for building reactive applications in Angular. It provides a Redux-inspired architecture that uses RxJS to work with reactive programming. NGRX store is the core principle that allows for state management in a single immutable data structure called the store. Actions describe unique events that are dispatched from components and services. Reducers process those actions to modify the store's state. Let's explore how to set up a basic NGRX store. The code snippet demonstrates how to integrate NGRX store into an Angular application. Store module.forRoot method is used to register the root reducer with the Angular application. In this case, we have a counter reducer that manages the state of a counter. The count reducer argument to forRoot maps the state key count to the reducer function. This setup lays the foundation for managing state globally within the app through the NGRX framework. NGRX store, actions, reducers, and effects. NGRX is a framework for building reactive applications in Angular. It is based on Redux, a popular pattern for managing state in applications. The NGRX store provides a way to manage global state as a single immutable data structure. Actions describe state changes, reducers handle these actions to modify the state, and effects deal with side effects. The code defines a simple NGRX setup. An action login is created with createAction, carrying a user property. The initial state for the store's user slice is set with user as null. A reducer user reducer is defined with createReducer, updating the state upon receiving a login action. Finally, an effect, login effect, is set up using createEffect to handle side effects, such as asynchronous operations like API calls, triggered by the login action. This setup exemplifies how actions, reducers, and effects work together in NGRX for state management. Dev tools for debugging. When building applications with Angular, especially those with complex state management, using development tools can significantly ease the debugging process. Tools like Redux DevTools can be integrated to provide a powerful interface for monitoring and manipulating the application state in real time. In the code snippet above, we first dispatch an action to the store using this.store.dispatch new myAction. Then, we log a specific slice of the store state using this.store.select myFeatureSelector. When using Redux DevTools, this process allows us to visually trace how actions modify the state, making debugging more intuitive. The tool captures dispatched actions and state changes, allowing developers to navigate through state history, which simplifies identifying issues and understanding application flow. Best practices. In Angular, managing state efficiently is pivotal for building responsive, scalable, and maintainable applications. Here, we delve into best practices for state management that help streamline app development. The code snippet illustrates a best practice in Angular's state management. Dispatching actions to modify the state, rather than mutating it directly. This practice ensures that all state changes are predictable and trackable, making debugging and testing easier. By using a centralized store, e.g., NGRX store for state management, this pattern enables an application to maintain a single source of truth, enhancing performance and developer productivity. Change detection strategies. In Angular, change detection is a mechanism for synchronizing the state of the application with the UI. However, depending on complexity, the default change detection strategy may result in performance issues. Angular provides two strategies to optimize this: default and onPush. By altering the change detection strategy to onPush, you instruct Angular to perform change detection only when new references are passed to components, or when an event originated from the component or its children occurs. In this code snippet, we define a component and explicitly set its change detection strategy to onPush. This means that Angular will now skip the change detection cycle for this component unless one of the following occurs. A bound input property changes its reference, not just its value. An event occurs within the component or its children, or manual intervention via change detector ref. This strategy can significantly improve performance in large, data-heavy applications by reducing the frequency and scope of change detection checks. On-push change detection. On-push change detection is a strategy used in Angular to improve the performance of applications. It tells Angular to check for changes in a component only when its input properties change or when events it subscribes to emit values. This is more efficient than the default strategy, which checks for changes more frequently. In the code snippet, we define a component with the @component decorator, specifying the change detection property to change detection strategy.onPush. This instructs Angular to update the view of example component only when its input properties change, or when it emits or subscribes to observables/events. It significantly reduces the number of checks Angular needs to make, improving performance, especially in complex applications with many components. Lazy loading modules. Lazy loading modules in Angular allows for the loading of module resources on demand, rather than at the startup. This significantly enhances the app's performance, especially in applications with numerous features and routes. It works by splitting the application into several bundles and only loading them when required by the user, thus reducing the initial load time. In the provided routes configuration, we define a route with a path feature. Instead of loading the module immediately, we use the load children property with an arrow function that dynamically imports the feature module. This import is only triggered when the user navigates to the feature path. The then method receives the module and returns it, ensuring that the module and its components are loaded lazily. Detaching the change detector. Angular performs change detection on every component to update the DOM whenever data changes. However, in some scenarios, you might want to manually control this process for performance reasons. Detaching the change detector allows you to prevent Angular from automatically checking for changes in a component. In the given code, change detector ref is injected into the component's constructor, granting access to change detection methods. This .cd.detach detaches the change detector, stopping automatic change detection. This is useful for optimizing performance in cases where you know updates are unnecessary. When you need to update the data and want Angular to check for changes, this .cd.reattach is called to reattach the change detector, allowing Angular to resume automatic change detection for this component. Track by function for str_ng4. In Angular, when iterating over a collection using n4, Angular has to re-render the entire DOM tree if any item in the collection changes. This can lead to significant performance issues for large lists or complex components. To optimize this, Angular provides the track by function. It helps Angular track which items have changed, been added, or removed by comparing a unique identifier instead of the entire object. In this code snippet, we define a component with a list of items, where each item has an ID and name. The ngFor directive iterates over the items array, but with the use of the track by fn option, Angular is informed to track each item by its ID instead of its entire object reference. The track by fn function takes an index and an item as its arguments, and it returns the unique ID of each item. This significantly improves performance, especially when updating the list, because Angular only needs to re-render the items that have actually changed. Ahead of time, AOT compilation. Ahead of time, AOT compilation converts your Angular HTML and TypeScript code into efficient JavaScript code during the build phase before the browser downloads and runs the code. This process improves performance by speeding up the rendering of your application, decreasing the size of the application's payload, and improving the security by compiling HTML templates and components into JavaScript files before they run in the browser. The code snippet ng-build task_prod triggers the Angular CLI to perform an AOT compilation as part of the build process for a production environment. This command compiles the app, minifies the output for JavaScript and CSS files, and sets environment variables for production, optimizing the app's performance. Introduction to unit testing in Angular. Unit testing is a crucial part of software development that allows developers to ensure individual units of source code, such as functions or components, work as expected. Angular provides built-in support for unit testing with Jasmine and Karma, where Jasmine is a behavior-driven development framework for testing JavaScript code, and Karma is a test runner. This code snippet demonstrates a basic unit test in Angular using Jasmine. The describe function defines a test suite for app component. Inside it, the eat function defines an individual test case, checking if app component can be successfully created. Testbed.createComponent app component initializes the component and the test environment, while expect_app to be truthy asserts that the instance of the component exists, indicating that the component has been created successfully. This pattern of testing ensures that components behave as intended in isolation, which is fundamental in building reliable Angular applications. Testing components. Testing Angular components involves verifying their behavior in isolation from other parts of the application. This includes checking template rendering, class properties, and method outputs. We use testbed and component fixture to create a testing environment for our components. In the code snippet, we start by importing necessary Angular testing utilities and the component under test. Testbed is used to create an Angular testing module where we declare the component to comprehend its standalone behavior. Creating an instance of component fixture for my component allows us to control and inspect the rendered component instance for testing purposes. The before each block initializes the testing environment, and within the it block, we conduct an initial test to confirm the component's successful creation. This setup provides a foundation for more detailed tests, such as checking outputs, interactions, and integrations. Testing services. In Angular, services are often used for business logic or to abstract the communication with back-end servers. Testing services is crucial to ensure they work as expected. Angular provides tools such as testbed and inject to facilitate testing. Typically, we test a service's public methods and their interaction with dependencies like HTTP client. In this code snippet, we're setting up tests for a service named myService. We start by importing testbed from Angular's core testing package, which allows us to create a dynamic testing module. Inside the describe block, we initialize our service before each test using testbed's configure testing module method to set up the test environment, followed by testbed.inject to instantiate the service. Finally, we write a simple test to check the service is correctly instantiated by expecting its truthiness. This basic pattern is extendable for testing more complex behaviors, such as service method outcomes and interaction with other services. Jasmine and Karma setup and configuration. Jasmine is a behavior-driven development framework for testing JavaScript code. Karma is a test runner created by the AngularJS team. It allows you to execute tests in multiple real browsers. The setup and configuration process involves initializing Karma in your Angular project, which by default uses Jasmine for test cases. Firstly, the Angular CLI is installed globally using npm. Then, a new Angular project is created and navigated into. Lastly, ng-test command is executed to start Karma with Jasmine. This command automatically creates a karma.conf.js file with default configuration. The file configures browsers, patterns for test files, and sets the testing framework to Jasmine. It's the starting point for further customization. Mocking dependencies. In Angular unit testing, mocking dependencies is vital for isolating the unit under test and to control its behavior in a predictable way. This allows tests to focus solely on the functionality of the component or service being tested, without the need to deal with complex dependencies or side effects from other parts of the application. In the provided code, mock dependency service is a mock class created to simulate the behavior of a real service dependency of some component. The getValue method is overridden to return a predetermined value. In the test setup before each block, an instance of mock dependency service is created and passed to the some component constructor, thereby injecting the mock service as a dependency. This setup ensures that when testing some components use dependency method, the actual implementation of the dependency is not called, but the mock implementation is used instead. This isolates the test to only verify the functionality in some component that utilizes the dependency, ensuring the test is focused and reliable. Testbed and asynchronous testing. Testbed is an Angular utility for configuring and initializing an environment for unit testing with Angular testing utilities. It allows you to simulate the Angular dependency injection system. In this code snippet, testbed.configure testing module is used to initialize the testing environment for a component named myComponent. This method takes a metadata object where you can specify declarations, imports, providers, etc., much like you would do in a typical ng module. This setup is essential for component testing, as it prepares an end module-like environment where components can be tested in isolation. Production builds. When preparing an Angular application for production, it's crucial to optimize its performance, size, and security. Angular CLI provides a simple but powerful command to create a production build, which employs ahead-of-time OT compilation, minification, uglification, and dead code elimination to enhance the application. The command ng-build-prod triggers Angular CLI to compile the application with production settings. AOT compiles HTML and TypeScript code into efficient JavaScript before the browser loads the app. Minification removes unnecessary whitespace and comments, while uglification renames variables to shorter names. Dead code elimination removes parts of the code that are never used. Together, these processes reduce the application's size and loading time, improving the overall user experience. Deploying to a server. Deploying an Angular application to a server involves preparing the production build and transferring it to your hosting environment. This is done using the Angular CLI to create an optimized version of your app. The ng-build-prod command compiles the Angular application into an output directory named dist at the root of the workspace, using production settings. This includes optimizations such as minification, which compresses the code, uglification, which rewrites the code to reduce its size while keeping it functional, and ahead-of-time AOT compilation, which precompiles Angular component templates. The resulting files are static and can be served from any web server or hosting platform. Angular Universal for server-side rendering. Angular Universal allows your Angular application to be rendered on the server before being served to the client, improving performance, especially on mobile and low-powered devices, and assisting with SEO. Implementing Angular Universal involves setting up your Angular application to enable server-side rendering. The code represents steps to add Angular Universal to your project and run it. ng-add @enduniversal/express engine adds necessary dependencies and configurations for Angular Universal using express.js. npm run build SSR builds your Angular app for server-side rendering. Finally, npm run serve SSR starts a Node.js Express server to serve your Angular app with server-side rendering enabled. This allows you to see the server-rendered version of your app on localhost. Progressive Web App (PWA) support. Progressive Web Apps (PWAs) are web applications that use modern web capabilities to provide a user experience similar to that of mobile apps. Angular provides built-in support to help you easily transform your app into a PWA. This command performs several tasks. It updates your Angular project to include the @Angular Service Worker package, which is essential for PWA functionality. It also adds a manifest file and icons, enabling your app to be installed on a user's device. Furthermore, it configures your app to use a service worker that helps in caching assets and managing network requests, significantly improving performance and enabling offline functionality. Angular Style Guide and Best Practices. Following Angular's Style Guide promotes consistency, readability, and maintainability throughout your application. Here, we'll discuss essential parts of the Style Guide, focusing on file and component structure best practices. This code exemplifies some best practices mentioned in the Angular Style Guide. First, the component is cleanly separated into its TypeScript class, HTML template, and CSS. The selector follows a kebab case naming convention, promoting readability. The file naming scheme, with each file's purpose, component, template, style clearly marked, also adheres to best practices. This structure supports easy identification and maintainability of components within larger applications. Upgrading from AngularJS to Angular. Upgrading from AngularJS version 1.x to Angular version 2+ can seem daunting due to fundamental differences between the two frameworks. However, Using Angular's upgrade module allows for a smoother transition. This module enables the two frameworks to coexist in a single application, allowing for incremental upgrades. In the provided code, the upgrade module from @Angular's upgrade static is imported and added to the ng module's imports. This setup configures the Angular application to accommodate an AngularJS application, your AngularJS app. The ng-do-bootstrap method is overridden in the app module, where the bootstrap method of the upgrade module is called. This method bootstraps the AngularJS application within the Angular application, specifying strict D as true to enforce strict dependency injection in AngularJS, enhancing error checking and performance. Using upgrade module. When upgrading an AngularJS application to Angular, one effective approach is to incrementally upgrade parts of the application using upgrade module. This allows for running both AngularJS and Angular side by side in the same application. In this code, upgrade module is imported and added to the ng module imports array. The app module class is then defined with upgrade module injected into its constructor. The ng-do-bootstrap method is overridden to manually bootstrap the AngularJS application, your AngularJS app, using the upgrade instance's bootstrap method. This setup allows for both Angular and AngularJS components to coexist within the same application, enabling a smoother migration path from AngularJS to Angular. Hybrid application strategies. Creating a hybrid application involves running AngularJS, the older version, and Angular, the newer version, side by side in the same project. This strategy allows for incremental upgrades, with parts of the application running in AngularJS, while new features are developed in Angular or existing parts are upgraded. In the code, we import upgrade module from Angular's upgrade static, which is crucial for setting up a hybrid application. The Angular module is defined as usual, with the inclusion of upgrade module in the imports array. In the app module class, the upgrade module is injected into the constructor, and its bootstrap method is invoked within ng-do-bootstrap. This method takes as arguments the DOM element to bootstrap the AngularJS application onto, the name of the AngularJS module, and an options object, strict-I-true, to enable strict dependency injection. This setup bootstraps the AngularJS application within an Angular environment, enabling both frameworks to coexist. Schematics and blueprints. In Angular, schematics are tools that support the application development workflow, particularly in initializing, updating, and managing projects. They act as blueprints guiding the Angular CLI on generating files when commands like ng-generate are used. Let's explore a simple example of custom schematic creation. This code defines a basic schematic named Hello World. It uses the rule function, which operates on a file tree and returns a new tree transformed based on rules. Here, a new file, hello.txt, containing the text Hello World is created. This illustrates how schematics serve as blueprints that tell the CLI what files to generate and how to modify them. Custom schematics. Custom schematics in Angular allow you to define reusable blueprints for generating or modifying code in your projects. They're a powerful tool for automating repetitive tasks, enforcing coding standards, and integrating with other tools or libraries. This simple schematic creates a new file named hello.txt containing the text Hello World. The Hello World function is exported and defines the behavior of the schematic. It takes options for potential future configuration. The rule returned by the function manipulates the file tree, in this case, creating a new file. The context.logger.info is used to log a message indicating successful file creation. This illustrates a basic schematic structure. Import necessary functions, define and export a function that returns a rule, and manipulate the tree for code generation or modification. Angular libraries creation. Angular libraries allow you to organize code in a reusable way across different Angular projects. Creating a library is a straightforward process with the Angular CLI. Below is a basic example of how to create and build a library. The first command, ng-generate library mylib, creates a new workspace library named mylib, including a component and a service. This sets up a project structure suitable for library development, including Angular module files. The ng-build mylib command then builds the library, readying it for publication or inclusion in other projects. The build artifacts are stored in the dist directory. workspace configuration, and multi-project setup. In Angular, a workspace allows you to manage one or more projects, such as applications and libraries. A multi-project workspace is advantageous for developing a suite of applications that share a common library, or for separating a large application into smaller, more manageable pieces. Here's how to configure it. First, we create a new workspace named My Workspace without a default application using -create application = false. Then, we generate a new application within this workspace named My App. Lastly, we create a library named MyLib within the same workspace. This structure allows for shared code, libraries, and multiple applications within a single workspace, facilitating better project management and code reuse. Angular CLI builders. Angular CLI builders allow developers to extend or customize the Angular build process. They are used for tasks like building the application, serving it during development, running tests, and more. Builders are defined in the angular.json configuration file. The code snippet shows a basic configuration of a builder in the angular.json file for the build process of an Angular application. It specifies the builder to use @Angular devkit build Angular browser and includes various options like the output path, the main entry file, and the list of assets and styles. This configuration is essential for customizing how your application is built and optimized for production. Integrated Development Environment (IDE) setup. For Angular development, setting up an Integrated Development Environment (IDE) is crucial. IDEs like Visual Studio Code (VS Code) offer powerful features such as IntelliSense, debugging, and extension support that significantly enhance productivity. This example will guide you through setting up VS Code for Angular development. This process begins with installing Visual Studio Code, a popular IDE among Angular developers, from its official website. After installation, you enhance its capabilities by adding the Angular Essentials extension pack. This pack includes a collection of extensions beneficial for Angular development, such as Angular Language Service, Angular Snippets, and others. It simplifies tasks like code completion, snippets, debugging, and formatting. Installing this pack essentially prepares your IDE with the necessary tools to efficiently work on Angular projects. Extensions and plugins for Angular development. Among the many tools that enhance Angular development, Visual Studio Code (VS Code) extensions are particularly valuable. These extensions can streamline your development process, offering features like syntax highlighting, code snippets, and linting. One popular extension is the Angular Language Service, which provides a richer editing experience. This command uses the Visual Studio Code extension marketplace to install the Angular Language Service. Once installed, it significantly enhances the developer's experience by offering auto-completions, error checking, and hover information in Angular templates. It understands Angular's syntax and semantics, providing insights that are otherwise not available in a plain text editor. This extension is essential for developers looking to streamline their Angular development process. Angular DevTools for Chrome. Angular DevTools for Chrome is a browser extension that provides developers with tools to understand the structure of their Angular applications and debug them more effectively. Once installed, it can significantly streamline the development process, especially in terms of performance profiling and component inspection. Angular DevTools doesn't require code snippets for basic use. It integrates directly with Chrome's developer tools. After installing the extension, open Chrome's developer tools, and you'll find a new Angular tab. This tab shows a component tree, allowing you to inspect component properties and the application's structure. It also provides a profiler to identify performance bottlenecks by tracking component rendering times and change detection cycles. Essentially, it acts as a bridge between your Angular application and Chrome's developer tools, enhancing your ability to diagnose and debug issues. Third-party libraries and integration. In many Angular applications, you'll find the need to incorporate functionality from third-party libraries. This might range from UI frameworks like Angular Material or Bootstrap to utility libraries like Lodash. The process generally involves adding the library to your project, importing it in your Angular modules, and then utilizing it in your components or services. In this example, we're incorporating the ngx charts library a popular Angular charting library that provides a wide array of chart options. First, the library is added to the project, not shown, typically using npm or yarn. Then, the gxcharts module is imported from the @swimlane/ngxcharts package and added to the imports array in the ng module decorator of your application module. This makes all of ngxcharts components and services available for use in your application. Internationalization process. Internationalization, I18N in Angular, refers to the process of designing and preparing your app to be usable in different languages. This involves externalizing text content into translation files so you can manage multiple languages easily. Let's start with setting up Angular I18N. First, we add the @angular/localize package to the project by running the command ng add @angular/localize. This package is essential for enabling internationalization features in Angular. Then, we wrap the text we want to internationalize in the I18N tag in our templates. This tag signals to Angular's I18N tools that the text within should be extracted and made available for translation. This basic setup is the first step in preparing your app for international audiences. Localizing Angular applications. Localizing Angular applications involves adapting your app to different languages and regions. This process includes translating texts, formatting dates and numbers, and possibly changing layout directions. Angular provides tools and workflows to make this process easier. Here, we'll focus on a simple example of extracting translatable content and preparing it for localization. The command ng xi18n output path locale extracts translatable content from your Angular app into an XML file. This file is then used by translators to provide translations for different languages. The jashed output path option indicates where to save the extracted file, in this case, a directory named locale. This is the starting point for localizing your Angular application. Using Angular I18N tools. Angular's internationalization I18N library provides tools to translate your application into multiple languages. This involves marking texts in your templates for translation extraction, generating translation files, and configuring your app to use these files. Let's explore marking a piece of text for translation. This code demonstrates the simplest use of Angular's I18N tools within a template. Adding the I18N attribute to an element marks its text content for extraction by Angular's I18N processes. Later, during the build process, Angular extracts these marked texts into a file which translators can use to provide the corresponding translations. The translated texts are then loaded back into the app based on the user's locale, allowing the application to display content in the user's preferred language. Locale setup and currency, dates, time formats. To deliver a seamless user experience across different regions, Angular applications can be internationalized to accommodate various languages, currencies, date, and time formats. This involves setting up the application's locale and configuring the format for currency, dates, and time according to the user's regional settings. The example below demonstrates how to configure locale and utilize Angular's built-in pipes for currency, date, and time formatting. First, the register locale data function and the French locale data are imported from @angular/common. The French locale data is then registered with the application. This setup enables the application to understand and format values according to the French locale conventions. In the template, the currency pipe is used to format a price value in euros according to French formatting, which includes the currency symbol and specific numeric formatting. Similarly, the date pipe is used to format a date variable, myDate, to a full date format and a time variable to a short time format, both following French locale standards. This demonstrates how Angular applications can support different locales by formatting currency, date, and time according to user regional settings.